I'm part of the Kusto team at Microsoft. I've been with Microsoft many years, left and came back a few times. And I'm glad to be here. I'm talking to you from Jerusalem, Israel. So time here is 9 p.m. right now. I have a few slides. I will just go through the slides very quickly and then go to some demos. I have quite a full agenda, so I hope I will be able to cover everything. And in any case, I think you will have my email. If you have any questions around this area, you'll be able to follow up with me later. And I'll be happy to help you if you have some engagements that you think that you can use this the tool that I'm going to show you. So we're going to talk about same product with many names. Kusto is the original name that was given to it by the group of people that created it at Microsoft. Those were 4 guys that worked actually in Power BI, and they were working at the time on the porting of the analysis services engine to Azure, what eventually enabled what we know now as the Power BI service and analysis services in Azure. They did this, and they were looking for something more challenging, and also they thought that there's a need for a tool to manage logs of services in large scale. There were other third-party products used in Microsoft at the time for this purpose, and they had some ideas that they were convinced that they can do it better. And so they started to work on this project in a kind of a stealth mode, at first without any authorization, then with local authorization. And then they went to ask permissions from Scott Guthrie, and he said no, and they still continued. And eventually they created a product that in a few years, they managed to convince pretty much every engineering group at Microsoft to use it for managing the logs, and also to base many products on top of this platform, like Azure Monitoring, App Insight, Sentinel, and many other products within Microsoft. And I think that it's mentioned in one of the slides. You can see how many Office logs, Windows logs, Azure logs, everything is managed in this tool. And it's called Kusto, and the official name is Azure Data Explorer. And within CNAP, it's Azure CNAP Data Explorer, but all of them are the same. And probably I will sometimes say Kusto, and sometimes I will say ADX. So the main scenario, it's a database. It's a database that its main scenario is to be used for telemetry, where there is high variety of data, which some of it is structured in regular columns, some of it is JSON, some of it is just plain text, and you want to extract from the 3 types of data. The data comes in very fast, huge volumes. We're talking about tables that at the high end reach the trillions of rows. Mainly, we live in the area of billions to tens of billions to hundreds of billions, but there are also quite a few cases in which it goes into the trillions. And usually this is timestamp, and we're talking about managing time series and all kinds of discoveries of anomalies or forecasting on top of time series. Another term that is used in this area is observational analytics, which sometimes people just compare it to regular analytics. We talk about one of the things that comes with this territory is that business questions change and the schema changes accordingly. So many times it's actually very convenient to put at least part of the data in structures like JSON columns, which you can add a column without just doing any change. So in some part of the rows, you can have some columns inside the JSON, and then in other columns, in other rows, it would be different, or you will add some, and you don't have to do a lot of work to manage these changes. And also what is really typical is that you want to see the data very close to the actual event that are happening in the real world. It's not like you do a sales analytic and someone goes to a store and buys something, and people are really happy if they can see the results of this purchase the next day. We're talking about people who want to see in their report the event after seconds, half a minute, a minute. And this is what we do. Just one example, I streamed a lot of slides, so I'm jumping ahead. There's a slide here about one of the extreme cases of use of a very focused use of our product during Super Bowl 2021, where CBS was streaming this to 5.7 million users on average during the game, and they were monitoring the behavior and the routing and all this. And they created a cluster of ADX with 600 machines, and you can see here the numbers: 175 records per minute. And then they scale it down after they finished. They went back to their normal behavior. Just some names of customers. in different areas. So you see on the left side, Microsoft product that put their logs in the Kusto. In the middle, you see Microsoft services, which are actually based themselves on the backend on the Kusto. So if you work with the Azure Monitor, you might be not exposed directly to the data behind it, but they created a multi-tenancy environment around our product. And on the right side, you see some names of some of our large customers, many in the security area, but also in manufacturing and in many other areas. So you see here a list of verticals that we do a lot of IoT, a lot of oil and gas, energy, like wind turbines, solar turbines, which produce large amounts of data. Automotive, it's like connected fleet, connected cars, trucks, and so on. But also, I've been involved personally. My job in the team is to work on the integration between Power BI and Kusto. And as part of that, I'm seeing scenarios that we can call just regular analytics, regular BI, sales analytics, bank analytics, but just in large scale. So a scale that is very difficult or close to impossible to actually implement with Power BI, because it goes to the limit of the biggest configuration that you can have in Power BI if you want to import the data into Power BI. So you switch to something like our tool, the Kusto, and you use direct query. So most of the work that you do with Power BI and Kusto will be in direct query. And of course, I'm going to show you how I do it. Some numbers, we totally so it's fully managed. So we manage all the machines in Azure. People configure clusters and they set the size of this cluster, what type of machine and what regions they want to have it, and so on. Altogether, we manage 8.5 exabytes, which an exabyte is 1,000 petabytes. So 8.5 exabytes of data with 1.3 billion queries per day, 85 petabytes of new data ingested daily. Now, data is only ingested newly. It's an append-only database. This is one of the reasons it's so fast, because we don't do transactions, we don't change the data. It's just you add more and more and more data. There are solutions in cases you need to delete. Sometimes you need to delete because of compliance reasons. Sometimes you want to delete because there was some data that entered in by mistake. There's some duplicate and you want really to take care of it. But mostly it's append-only data, just new data comes all the times. The pricing, there is, you can go to ak.ms/adx.cost, and there is a calculator that helps you calculate how much it will cost you. Mainly, the main thing that determines the cost is, of course, the number of machines that you want in your cluster. The number of machines can be fixed or it can be flexible based on the load. And what you will be asked in this calculator is mainly how much data you're going to enter every day, and for how many days you want to keep this data hot, in hot cache. Our hot cache is in SSD, in solid-state devices that are connected to these machines in Azure. And this is why one of the reasons we achieve such speeds is because everything is in SSDs, and also because we distribute everything between the nodes. And you can have 2 nodes, or you can have 10 or 100. It scales up to 1,000. We have a few clusters which actually are already reached the maximum number of machines that you can have, and they have 1,000 machines in Azure. I will make available later the presentation, so you will have a lot of links to all kinds of documentation, blogs, and so on. So this was everything I created as a PowerPoint, and now I'm going to switch to the product itself. Let me go here. Okay, so what you see here is our web tool, the web environment. Actually, I should have started it from home. Usually you start something from home. So dataexplorer.azure.com. This is the web tool that you use for different aspects. Of course, when you start, really, you probably go first to the Azure portal to configure a cluster, or you go here, and one of the areas here is enables you to create a free cluster. We offer a free cluster that you don't need anything for. You don't need a credit card or an Azure subscription or anything. The only thing you need is a Microsoft account of any kind. It could be your personal Gmail that you just register as a Microsoft account, and then you get a free cluster that you can ingest. You can get data in. You can start querying it, and it allows for significant volumes of data. In this free cluster, we actually implement a technology of virtual clusters. So these clusters are actually hosted within one or a few big clusters in the different regions, and you get just a slice of it, and you can place. So you either start in the portal with a real production cluster, or you start with your free cluster. So from home, after you created your cluster, you can and you create a database also in the portal or in here in the free area, and then you can go from there and you can start working on data. You can ingest data. I'll just go very quickly. I'm not going to spend time on the technologies of ingestion because I want to go spend as much time as I can on the purpose of this presentation, which is Power BI. But I need to set up in general to let you understand what is this environment that I'm talking about. So from here you can go to ingestion. You can say what is your cluster, what is your database. Is it a new table? And if you say, I don't know, I want to create a new table, you go, and here you can say, I have the data ready to be loaded to the cloud from a local file or from a blob or blob container, event hub, all kind of different options that you can do. So the whole area of ingestion is, we have lots of options for streaming data or uploading files as they come, using other tools like Kafka, Spark. There's tons of it. It's not my area of expertise, and I'm not going to spend too much time on this, but eventually you'll get the data in, and data probably will come and continue to stream in periodically, and data will just grow and grow and grow. Next area, and the area that you'll spend most of the time here and also if you start using the product, is the query area. And this is the query environment. Here I'm using the web product. There is in parallel to this, there is a Windows program that you can install. It's called Kusto Explorer. You install it. It's more advanced. It has some more functionality. Usually, a Windows application is richer than a web product, although this web product with the web tool is quite sophisticated. But so you can choose between the Windows tool or the web tool. Now, what do we see here? We see here a hierarchy of clusters. Within clusters, we see databases, and within databases, we see other objects like tables, functions, and some other objects that we don't see here. There's something called materialized views, and there's also something called external tables, which could be like SQL Server tables that you connect here, and you use the language, our language that I'm going to show you. You can go against external tables which are not actually inside our environment. They're sitting in SQL Azure and some other databases on Azure. Now, one cluster, the health cluster, is going to be available the moment you go here. If you didn't even configure a free cluster, you always have access to the health cluster. So the health cluster has a few databases. One of them, I assume, will be familiar to you, as I guess you are coming from a BI background. And this will be the Contoso Sales. So it's a subset of the Contoso data warehouse. And I have here the sales information in two flavors. I have one table that is a flat table, which includes the measures like sales amount and cost, and also detailed information that came from the product dimension and the customer dimension. So everything is one flat table, which is actually the ideal case for our tool. So the best way you can present the data will be just in one table. The other option is that I have here something called sales fact, and it only have the two measures, the two numeric value, the sales amount, the total cost, and then I have keys for three other tables, and the tables are here: products, customers, which already customers also include what initially is from the geography dimension, so all the geographical information plus details about the customers. Now, if I start, now the language that you use to query the data in Kusto is called KQL, Kusto Query Language, and it's not SQL. We do support SQL, so you can go here and start writing SQL. You can say select, count from, I don't know, customer. And I can run it, and I can see the number of customers. But, so we know how to answer to SQL, but this is mainly used for other tools which can connect but cannot create KQL. They're designed, they use ODBC connectors, ODBC drivers, or JDBC or something that, so every tool that can connect to SQL Azure, we can present ourselves, the cluster can present itself as SQL Azure. And then you can start sending to it SQL. The SQL is not full implementation of everything in SQL, and it's definitely not the recommended way to go. And I hope I will be able to convince you that that KQL has a lot of advantages over SQL. SQL has been with us, it's close to 50 years. So and KQL it's relatively modern, and it was designed for this kind of work. So how do I start? I start by just clicking the name of a table. Just clicking the name of the table is the equivalent of select star from table. So just I say the table, I have everything. So now, because I start with the table and not start with the word select, now IntelliSense will kick in and will know exactly what do I have available to me. I can start by something very simple, just using the operator count. And this will be just give me the number of rows. So this is a table that we will consider very small, 2.8 million. If I want to start doing some summaries over it, I will use something called summarize. And I can say summarize sales equals sum of sales amount by. And now I don't have a lot because I did not join this with. So let's, instead of sales fact, let's start with the one before because of course I can do join. This is designed for joins, but if I start with sales table, I have a lot more options. So now actually IntelliSense will give me a full list of everything that is available for me now. And I can say, I don't know, I want to do the summaries by color name and country, let's say country. Okay. I use Shift Enter to run the query. And here I see by each there are 95 combinations of color and countries. And I can see here the data. I can also, if I just let's say by color name, I can also render here a chart, so I see a column chart and also I see the table. All right, and then I can continue. So not after render. Render is a special case, which is the end of the story. There's nothing after it, but before that, I can have an pretty much endless list of steps. For example, if I want to filter the data, I can use the where, and I could say where gender equals F. And I could say also and country in France, Germany. The tool is case sensitive. There are operators which are case insensitive. They of course are less efficient. So this here I have a where clause, and also I can add something here. For example, I can say instead of by color name, I can say by bin of the date key. Yeah, date key, comma 30 days. I don't know. I want to bin the dates by 30 days, and that's why I do it. So now I get keys separated by each from the beginning by 30 days. Probably I want to see it ordered. So, and I want to do it descending. The default sort order is descending. So, all right. So we saw a little bit of using this table, but let's switch to another tab here. And this tab here, oh, actually, this is the tab I was here. And I would I will switch databases and switch clusters. And I'm going to use a cluster which is internal. It's not something that everybody has access. Unlike the previous one that was that is the health cluster, which is open for anyone. This is an internal cluster that people within Microsoft use a lot for demos. One of the databases here, it's called GitHub, and it has a table called events from live stream. So if I say here events from live stream, and I want to just check how many rows do we have here. We have here 2,837,210,934 rows. If you remember this number, it ends with 934. If I run it again, you see that it changes because new data is streaming into this table as people are submitting and doing things on GitHub. So every operation that anyone does in GitHub is getting into this table. So that's why it's growing and growing and growing. If I want to see a little bit of what's the content of this table, I can say just take 10, which is like taking any 10 rows. And I see that I have an ID, a unique ID. I have a type of the event, and I have 3 columns which are actually JSONs. So if I click inside them, I see what are the contents of this, and what is the content of this, and what is the content of this. And although I can, if I want to do something simple, I can say, let's take only rows where the is greater than ago 7 days. So I don't have to do all kind of calculations. What was the date 7 days ago? And I want to say summarize count by type. So these are the numbers of rows that came. So last thing I do before I leave and I go into Power BI is to go even a step further to another cluster that has this database here. And in this database, there is some logs from SQL Azure from some years ago. And in one of the tables, this one here, let's take a look on the size of this table. This table is not growing, it's static. We just ingested into it a bunch of rows and that's it. But it has 41 billion rows. And I use it to show the abilities of going against text columns. So one of the columns, it's called event text. And if I take few rows, this is just text, and different events have different text. And I can start parsing this text in different ways by regular expressions. But I will just do something simpler. I know that in many of these rows, the event text contains actually, as part of it, a SQL statement. So I can say, I want to look for how many rows in this 41 billion have inside this text column, they contain a join. So I will say, where event text, and I don't even need to do this project because it doesn't matter. The database is columnar, so the fact that it has many columns doesn't affect me. If I'm going against the event text, only the event text column will be touched anyhow. So I don't have to select a few columns first and then go against them. So I didn't have to do the project necessarily. Project is like selecting which rows I want to see. So where event, and by the way, the speed you're going to see, which I hope you're sitting, because if not, you may be, something might happen to you, is achieved besides the spreading the query on all the machines and the parallelism and everything, is because we index everything, and we also index terms with words within text. So it's not just if we see something that we say, oh, we cannot index it. No, we index it to death. And so that's why I can do something like event text has, and has is the case insensitive way. If I wanted to do it more efficiently, they would say has underscore CS, but I don't know how they write. Did they write selected uppercase or lowercase here? So, and I'm just going to count. And I see that there are 148 million rows within the 41 billion that has the word select in the text column. Now, I never opened yet this tab here, the stats. So now I'm going to open it. And you see that the execution of the query took 1/3 of a second, but it consumed almost 29 seconds of CPU because many cores were doing this in parallel. And then all the results were combined to give us the number. And this is the amount of data that was scanned. It's mainly the indexes, the index of this column to look for the word select. Now, if I want to say, I want to look for join, this probably will be a smaller number, 33 million. But now I want to compare how many times people did in a join. $6 million. And now, usually I ask the audience, what do you think about full outer? If there were 6 million inner joins, how many full outers are there? So just pick a number and think about it while I do the query. 350, that's all. So full outer join is not really very popular. So I hope that you are convinced now that this can really give us very fast response time. And let's go into Power BI. So in Power BI, I'm going to get data. I'm going to select the connector to Kusto, Azure Data Explorer, parentheses Kusto, connect. And I'm going to start with a cluster that has the GitHub information. Demo11.westus is the name of the cluster. You can copy the name of the cluster from, if I go back for a moment here, if I go here and I go here, this is actually the full name of the cluster, but actually if I just write demo12.westus, the rest of it is fixed. It's always like this, so we don't necessarily need to include all the name. So I'm back here, and I do want to say direct query. Most of the work that I do with Kusto and Power BI will be in direct query. There is some fringe cases that I will use import, but usually one of two things is true, or both. Either the data is very big and it's very difficult to import, or totally impossible to import everything into Power BI, or you want the data very fresh. You want to see the data that came into this Kusto a minute ago, and you cannot achieve it by importing. You will not be importing every minute. So you have to go here, check direct query, and I could specify here the database, and I could specify here a table, or I can paste here a full-blown query and go from there. But instead, I'm going to do the more standard Power BI way of going through navigation and see the list of objects and selecting them. So here I go to the GitHub database that we already saw, and I go to the events from live stream table. You see the preview. I go to transform data. And now I can start doing transformations the way I do them in Power Query or any other source. So I can say ID, I don't need it, so you can go away. Also, I'm not going to do here anything with JSONs, although I can extract the data from the JSONs and start using them for analysis, but I don't have time for that right now. So I'm going to say that I'm going to remove also this, and this is anyhow a column that has one value, so definitely it has no. Now I can change the name. Let's say that I want to call this date time, and maybe I want to add a new column based on this very exact. It's actually more accurate than what you see here. The format here doesn't show all the parts. It goes to, I think, milliseconds. I want to say that I want a column that is just the date. Now everything I do, so I removed columns, I renamed the column, and I inserted the date based on another column. Everything here is being what is called in Power Query terms folded, which means translated to the native language of the connector, which in this case is KQL. So if I go here to the last step, right click, view native query, I will see the steps that actually are the KQL representation of what I just did through Power Query. So calling the table, then selecting just two columns out of it with the project statement, and then extending a new column, which is with some expression, just getting the date part from the created at column, and then projecting, renaming with the project rename the date, the created data, I've just renamed it to date time. And you can do many things. And I can actually decide to go here and do group by. If I do a group by here, so if I, let's say I do a count by type, then it will do it count by type, but I can also do it in Power BI later, so I don't have to do it here. So I will just delete this group by, because this is also going to be sent to the backend for execution. So actually you see that everything else disappeared. There is all this other steps that are actually not relevant because I didn't use them. So the only thing that's left here is project type and summarize by type. But I'm not going to do it here. I'm just going to close and apply. All right, so we have a tiny table with three columns. And I can let's do just a table. Because we're not into, I'm sure that you know how to create nice charts with Power BI, but I'm just going to do the type. So this is the list of all types that can be done in GitHub. And now I'm going to create a measure. So I'm doing many normal Power BI things using DAX, count rows of events. All right. Comma, and now I'm going to drag this to here. And I'm going to sort it here. So we see that out of the 2 billion and so it grew by a few thousand since we last visited this number. And this is how it's the breakdown by type. Now, if I want to start filtering it just to see recent data, I can take either the date, but I would prefer taking the date time. And I will do a slicer from it. Notice that creating the slicer took some time because it had to actually go against this 2.8 billion rows and collect all the different unique values of the timestamps, which is quite a large number. But I will use a type of slicer that I guess probably very few, let's say very few of you watching this now or in the future have ever used, which is a relative time slicer. So because the data is streaming in all the time, I can ask the question like, how many rows were added in the last 15 minutes by each type? And the answer is 35,000. And in the same way, I can say in the last 6 hours. And of course, in the last 6 hours, there were already over 1 million rows. So let's understand what happens here. So we had a query that we saw the syntax of it in Power Query. So this is the basis of this, what's going to be sent to the backend. Then the slicer is going to add its part and say where there is the calculation here of what does it mean 6 hours. It's the 12:43, 16 p.m. to 6. So this is from 6 to 12 p.m. UTC. So based on the time right now. So this is so there's a where that's going to be against the created date with this range. And then there will be a summarize that is actually triggered by the visual. So the visual says that the syntax of the DAX, very simple DAX measure that I created, the events, which is going to do a count rows. So the final query is made from the initial query that was in Power Query. Then added to it was the filters, any filter to slicer, cross-filtering if there is, and then each visual will actually request its own summaries, either from measures or from implicit measures. And so eventually everything goes to the backend, and you see that actually I can get the results very fast from a table that is almost, it's getting there to 3 billion rows. Okay, now for the rest of the time that I have, I want to go into a more elaborate example with something which is a feature of Power BI, which was designed pretty much specifically for our purposes for Kusto, actually a little bit before I joined the team, and it's called M dynamic parameters. So in order to do that, I'm going to switch back to here, and I'm going to introduce something called a function. Just a moment, where was it? No, this is not. Where was the function? I created a function. I probably. Oh, okay. This could be an example. Okay. So there is something called a function in Kusto. So this is an example of such a function. So I'm using everything that I used so far. Just excuse me for a moment. I will just start my ventilator because it's getting hot here. Let me know if it introduces too much noise, then I can switch to headphones. So here I'm using a command. Everything with a dot is a command. The command can be something like, for example, dot show cluster, which will tell me some information about the cluster that I'm using. How many machines does it have? In this case, now I'm actually in my personal cluster, which is the tiny cluster. And so everything starting with the dot is a command. Everything not starting with the dot is a query. Create or alter function. This is the name of the function. Events in last. Actually, I created 2 versions of it, and I'm going to use this one, creating event in last one. And it has a parameter called span, and the parameter has a type. The type is time span. What is time span? Time span is like when I do here. I think I used it before when I said, but I didn't introduce this operator ago. So let me switch for a moment to GitHub again, to the origin here. So let me just go to the bottom here, and I'll go again to event from live stream, where created at is greater than ago. And now I can use a time span. Time span can be something like 7 days, or 3 hours, or 15 minutes, or even seconds. And then I can, after I limit the number of rows, I can say, oh, okay, how many are left? And in this case, 30,000. So here, the function receives the parameter, wants a parameter of time span. But you know what? I will change it because for some technical reason, it's easier for me to deal with parameters in Power BI, which are strings. So I will just say it's a string. And immediately, the moment I change this to a string, IntelliSense is telling me that this is wrong, because if I want to do the ago, the parameter of the ago should be a time span, and this is now a string. So I will cast it to time span. There's a to string, to long, to int, to everything. So this is how we cast from one type to another. So the function is used. Now the function, I create a function in my personal cluster, not in the cluster where the data resides. The reason is because of rights. And if you want to experiment with this, you can actually create functions that go against data in the health cluster, but you can define the function in your personal free cluster. And so you can go with a query external to, you can go cross cluster, or you can go cross database. So here I'm saying I'm using a data which is in the cluster demo1.westus, the database GitHub, and the table is the event from live stream, which we saw already a few times. Now I want to create a new column called day, which is the beginning of the day of the timestamp. So based on the timestamp, just the beginning of the day. So midnight of this day, so representing just the day. And then I would say I want to minimize the data to day greater than ago. And then I'm using the parameter for specifying how much time back I want to do. And then I'm using a summarize count by type or day. Okay, so this is what the function is doing. I write a function, I actually run it because now I changed it. So I actually run this thing and it doesn't give me any errors. So I know I'm fine. I can actually test it here, events in last one. It gives me an error because I need to give it a string that will be converted to a time span. So I can say 6 hours as a string, and I will do count. So, what? Why is that? Oh, because I'm doing it on the day. So I need to do it on. So I will run it again, and I will run this again. Okay, so there were only 15. Oh, 15 is the result. So actually the function is returning summaries. So here are the summaries by type and by day of, and the counts of the number of rows in this parameter. Now, the reason for me showing you all this about parameters, about functions with parameters, is to go into Power BI and to create a report that will allow the user will be able to specify how much time to go back, but in terms of instead of using the slicer, I want them to be able to say 15 minutes or 3 hours, or just use the syntax of. So this is just an example, something that's similar to this you can do with the slicer I showed you. But let's assume that you want to do it with giving the parameter to the function. So I want to use the function, and using functions allow me to do things which go beyond what's the regular thing I can do, because I have inside the function, I have the full scope of the language of KQL, so I can express my logic in KQL, and then I can call the function and just give it the parameters, and it will give me the results. So let me just go and do another query. We don't have a lot of time, so again, now it's going to be against the cluster called Dany H.West Europe. It's the region. Here are the functions. So here's the tables, and here are the functions. And events in last one, I select it from the list. It tells me that it's looking for a parameter called span. I will just give it, I don't know, 2 hours. Apply. It will give me a preview. I'll go to transform. Now it's actually giving me using the default value of the parameter, but I'm going to create a Power Query parameter that I'm going to call it span. I need to be careful not to use any name here, which is a reserved word in DAX. There's a weird bug that I didn't fix. And here, again, I can say anything as a default value. And now I'm going to my original query, the event in last, and I'm going, instead of giving it a fixed value, I'm going to give it the name of the parameter. So again, it's still not flexible. It's just that it's using the parameter, but this is not enough. Now, before I leave here, I will create a table, a static table here, that I will show in a moment. I will explain why do we need it. You'll see it, but I just want to do it here as long as we're here. And I'm going to give a few values. So 15 minutes, 30 minutes, 1 hour, 3 hours, 6 hours, 1 day, 3 days, 7 days, whatever. All kind of values. All right, I can give it, make it so that it will be sorted correctly, but probably know how to do that. So I have here the results of this function, which is the list of but I want the user to be able to select the time span. So I'm going to create a slicer from this table, which is not related. There is no relationship, and the relationship will not help me because this is not a column in the table. It's just a list of values. But here I'm going to show you this very special feature. So I'm going to the spans table, spans column, to the advanced properties of it. And in here, I see something called bind it to parameter. And I'm going to bind it to the span parameter. So it means that every time someone will select a value in span, and I'm going to also say that it's not a multi-select. You can do multi-select, but I'm not going to do it. For this purpose, it doesn't make sense. In other cases, it will. And now it actually changes this to a single selection. And now every time I click something here, it actually goes, this value flows into the parameter, and the parameter triggers the query to run, and I get the results. Now, last thing I want to show you, if I remove this, so now I'm going back to my default, and instead of doing this in a slicer, I do it in a filter. Why will I go to a filter? Because the filter has a very nice feature called advanced filtering is. So now I can write anything I want. I'm not limited to the list that I create, because I cannot create a list of every combination of minutes. So what if I want to do 5.5 hours, which is a valid value for the time span? Yeah, it's possible. 171 minutes. For some reason, this is what I like. So now the value of, so everything I write here, I select a value. If I do a mistake and I say, I don't know, 171K, this will not work. Give me an empty, so the silent, nothing in. So, but as long as I'm writing valid time things, which could be converted to a time span, I'm fine. So now I think we should allow for answering questions.
Yes, that's a perfect time for that. So, first question, at what volumes or speeds does it start to make sense using the ADX, the Kusto?
Well, it's not so much about the limit, the lower limit. If we're talking about volumes, I would say if you start using the word billion, it makes sense for you, for anything. Or if you want to see the data very close, so you want to constantly stream in data and you want to see it seconds to minutes after the event happened. So in Power BI, in import mode, and with other tools, it would be very difficult to manage volumes which go beyond many billions. And also it's going to be difficult to see data which is very fresh, because the platform can ingest data in parallel in very high speeds, and also can maintain. So it's all a matter of linearly growing. So you add more machines, you can ingest more data faster, and you can query it faster. So I would say when you are outside the boundaries of import, or you want to see data very fresh.
Great. So next question is, given that the initial monthly cost of a production cluster seemed to be quite high, is cost really a big driver for companies in their choice of ADX for IoT stream processing over something like Databricks, for example?
We compete very well against all these tools in price. It's not anything special. We know how to use Azure in the most efficient way. We could be flexible in the number of machines that can grow and shrink based on demand. And we have different types of machines, different SKUs. We always look for the best SKUs. You can have machines which are storage optimized or compute optimized. You can, if you have a very high load of queries and you don't and not so much data. So you, instead of having more and more machines, you can have a special cluster that actually is called a follower, that you can have a whole population of users with heavy queries run against this separate cluster, and this cluster will do like a replication of the data to it without bothering at all the leader. So we have a lot of optimizations, and when we compete on price, we compete with all of this tools very well. With Google BigQuery, for example, because Google BigQuery, the main problem is that it charges for queries. Each query costs you money. We don't charge anything for activity, only for the actual machines. So it may seem high, but it competes very well.
This connector to Power BI, is it a normal driver so we can use that in our homemade applications as well, or is it bound to Power BI?
This connector is for Power BI. If you want to create your own application, there are APIs. There are APIs for different languages that you can use to access the data from Kusto. So you can use Power BI. You can use something like Grafana, which is it's an open source tool, but it also has managed Grafana on Azure. So Grafana is very well suited to cases in which you need really very fast response, and for IoT and things of this kind, people really love to use Grafana. So we have a connector for Grafana. So we have connector for different tools, and we have APIs if you want to create your own.
Cool. So as I understand things, all data that is analyzed by ADX must first be loaded into the ADX tables. So if that's true, the question is whether at some point in the future we'll be able to create virtual tables or views that attach to different data sources, such as how you see in data lake house architectures.
We do have capabilities of working with external tables, but there are limitations. We are dependent on our proprietary, the way we maintain the data on Azure. We use Azure storage, but we do our own indexing in our own columnar database, and without it, there's no way we can get this kind of performance. So we're going to stay with this, and we can read from data from the data lake. We can export data to the data lake, but in order to achieve the main goals of querying time series and all that, we will use our own format.
Juan L has a question that sets like this. You mentioned most Power BI projects would be using direct query. Have two concerns about it. One, potential slow speed compared to import mode. Is that so? And the second, I understand DAX becomes very limited in commands to use when using direct query. How do you work around such potential obstacles? He's working with Kusto in import mode, having bloated and slow datasets right now.
All right, so I would recommend that one contact me. So if you could write my email, Dany@microsoft.com, and I can publish it. And I think that if you know what you're doing, if you know the best practices, if you can get very good. And I hope I was able to show you how fast can it get with Power Query. So going against tables with billions of rows and getting very nice. So it's not as fast as import, because import is in memory. So there's no way to compare something in memory to something which is on the cloud, and you need to bring the data to you, at least in summarized form, and so on and so forth. But as long as it's in the sub-second or a few seconds response times, you can actually use direct query and then save yourself a lot of trouble of having huge tables and long time to import and all that. And there's no way you can actually get the data also to be fresh, to see the data that an event that happened a minute ago. So you can get very good performance with direct query. There's an issue with the relationships. You need to know how to do them or how to avoid them. We are actually fixing it we already fixed it in the September version of Power BI Desktop. The connector will know how to implement relationships and joins that are caused by relationships in a much better way. So this was one of the obstacles. The moment people try to relate multiple tables between them, the queries became very inefficient. And now we actually fixed it. I'm going to start writing about it now, because now in September, once people get the September version, they can start using relationships in a much better way.
Johan has another question. What is the cost associated with indexing and maintenance? And that leads to another thing. Can you create custom indexes, or do you by default index everything in the tables?
So the cost, you cannot really talk about the cost of indexing. The cost is the cost of the entire thing. So we compress the data, and you can think that actually we take on the storage on average between 1/5 and 1/10 of the volume of the original data. So after we index everything and we compress it and so on, altogether it will be still much smaller than what we started with. And the answer to the second part is you don't have any control on indexing. We index everything always, and the user have no say about it.
Right, I expect you're going to get this question a lot, or you have had it a lot. When should I create an Azure Data Explorer cluster as a standalone service over creating an Azure Synapse Data Explorer pool?
Yeah, that's a tricky one. It's a matter mostly, I think, of commercial. If you have an agreement, if you're working in a large company that already have some, you bought some, I don't remember exactly the terminology that you buy in Synapse, so you can use this capacity that you have for different services, including Azure Data Explorer. Other than that, I would say eventually, actually, it's a little bit even more expensive, unless you have a good agreement with Microsoft on that gives you better pricing. So your better option right now is to go on Azure Data Explorer. So just go on Azure and configure the cluster independently. There's nothing you lose. You can connect to all the sources on Synapse or data lakes and everything. So yeah, basically the same product, but some advantages to do it just standalone.
So when we are using other products like data lakes or delta lakes, we can do updates of the data from outside. Is there any way here to update the tables with SQL code or a REST API? And if there is, do you have a link to an example where we can find how to do this?
Basically, the answer is no. So you cannot really go to a data and change it. What people do, let me give you an example. We have a table, so we have our own, of course, a lot of internal data that we collect. Actually, every query that anyone in the world is doing right now is going to create between a few tens to a few hundreds rows in our logs. And our main log table is like 300 trillion rows, something really incredible. And one of the tables that we have is a table called dim clusters, which have all the clusters. And every few minutes, we actually get a dump of the status of all the clusters. Are they running or are they stopped? How many machines do they have? And what kind of machines are they, and so on and so forth. So we take, instead of updating the data, we take a new snapshot of the data every few minutes. Now we have something called the materialized view, which is connected to this table, and it's being updated as the data is coming to this big table. And in it, it actually have an aggregation that I didn't show you called argmax, with, you can say, give me the latest copy of the data by the timestamp for each cluster. So this materialized view will maintain the latest version. So as long as you have a unique key for the object that you maintain there, you can use this technique to have a materialized view with just the latest copy of a piece of information. So you might have in the big table all the changes, all the history of changes, and you can decide for how many days you want to keep it. You want to keep it maybe for a very short time, or you want to keep all the history for a full year, I don't know. And then in the materialized view, you will have the data latest copy, so with all the changes. So this is a technique used instead of going to a row and changing it. We don't change rows. We do have a way for two types of deleting. One is soft delete, which only flags the data as deleted, and one is really purge, which is much more expensive because it takes a long time. But we have to have it because for compliance reasons, there are some standards that force you to have a way to really delete data all the way, but no update. There's no APIs or anything for that.
Final question. Is Power BI and the Kusto connector able to perform any push-down optimizations to the underlying data set to improve cluster query processing performance?
Well, if I understand the question, so we do have an optimizer that does a lot of, so when you send your query, the optimizer that creates the query plan does a lot of iterations of trying to make the query more efficient before it runs it. For example, you do code a table, and then you do summarize, and then you do workloads. It will push the workloads if the workload is not on the results of the summary, because you might say summarize of count, and then I want to see only the elements that have a count greater than something. So then the word should actually be after the summarize. But if you do summarize by country, and then you say where country equals something, the where will be pushed before the summarize, as close as to the table as possible. So this is just a simple example, but there's a lot more. So we do a lot of transformations to the query, as long as these transformations are guaranteed not to change the semantic of the query. And also, we just limit it by the number of iterations. So after a few, I think there's a limit to how much effort we can put into optimization, but at some point, we'll spend more time optimizing than actually executing the query.
Excellent, thank you.
So that concludes the questions. Thanks to everybody for joining us, and a really big thanks to Dany.
You're welcome.